Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn about a normal approximation to binomial distributions. All right, so when we're checking for if a binomial can be approximated to be normal, we're going to check the large counts condition, which says that the probability distribution of x is approximately normal if n times p is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. We're going to let x equal the number of successes in a random sample of n from a population with a proportion of success equal to p. All right, using normal approximations, when the large counts condition is met, we can use a normal distribution to calculate the probabilities involving x, the number of successes, in a random sample of size n. So, mu, the mean of the random variable, is n times p, and the standard deviation is the square root of n times p times 1 minus p. The normal distribution we use to approximate the binomial distribution should have this mean and standard deviation. So this can kind of help us when we're having to find the probability that it's greater than a value or in between values, because remember with binomial, when you did the binomial CDF, you could only do the left tail. So if you needed it greater than, you had to do 1 minus. So if you can approximate it to be normal, you can use normal CDF instead. All right, so the large counts condition. It's estimated that 24% of all American adults have more debt on their credit cards than they have money in their savings account. Suppose this percentage is exactly correct. Let x equal the number of American adults with more debt than savings in a random sample of 40 American adults. Is the probability distribution of x approximately normal? Justify your answer. So n equals 40 and p equals 0.24. And I'm checking if it's normal, so I'm going to check the large counts condition. N times p, 40 times 0.24 gives me 9.6. N times 1 minus p, 40 times 0.67 gives me 30.4. Well, 9.6 is not greater than 10, so because n times p is less than 10, the sampling distribution of x is not approximately normal, and we have not met the large counts condition. All right, normal approximation to a binomial distribution. According to a Harris interactive poll, 23% of American adults would say that the most romantic Valentine's Day dinner option is preparing a home-cooked meal together. The random variable x, the number of American adults who would choose this option in a random sample of 800 American adults, has close to a binomial distribution with n equals 500 and p equals 0.12. Because n times p equals 60, which is greater than 10, and n times 1 minus p equals 440, which is also greater than 10, the probability distribution of x is approximately normal. Calculate the mean and the standard deviation of the appropriate normal distribution. So the mean is n times p. So 800 times 0.23 gives us 184. And the standard deviation is the square root of n times p times 1 minus p, which gives us 11.90. Okay, so we have 184 here in the center. We're going to go to 165, use the normal distribution to calculate the probability that 165 or fewer American adults in this sample would choose this option. All right. So we're shading here, and we get a normal CDF and 0.0552, so 5.52%. So remember, normal CDF, your lower bound, it's going to negative infinity, so we're going to put negative 99999, upper bound 165, mean 184, standard deviation 11.90. Alrighty, go Seahawks.